Vivek sir, please start the live streaming.
Sir, just a minute. Just a minute.
So now can you see my presentation?
Just a minute. To introduce you to the participants, and then we can start the session.
Okay. Can you see my presentation?
No, sir.
Because you have to check the screen sharing option.
Okay. Yes, it's in process.
Yeah. Can you see now? Okay.
The screen is
Oh.
yes,
Now
yes, we can see.
okay. Great.
You can maximize the screen. Sir.
Yeah. Yes. I was just checking it's working or not.
Yeah, yeah.
Yeah. Now we can start.
Yes.
So you have the clear voice, I think.
Yes. So just before that, I just want to introduce you to the participants.
Yeah. Sure.
So good afternoon, everyone, and welcome to the session 2 of day 3 of the online STTP, which is sponsored by AICT on the topic optimal operation of power system incorporating renewable energy sources. The topic for today's session is energy storage via battery by Dr. Alok Mani. We are fortunate to have you here with us, sir. Welcome. I heartily welcome you on behalf of Department of Electrical and Electronics Engineering, and I welcome all the participants who are here for joining. Before starting the session, I want to give the brief introduction of Dr. Alok Mani Tripathi. Sir is working in the field of material development and diagnostic of energy storage devices such as batteries and supercapacitors. He is trained in energy science and engineering from Indian Institute of Technology, Bombay, Mumbai, India. Presently, he is working at the Center of Material Science and Nanotechnology, University of Oslo, Norway, in collaboration with Norway's Energy Mission, Mobility with Zero Energy Emission System, that is MOSES in short form. He is also experienced to work at various international universities in the USA, like Washington University, UK, University of Manchester in UK, National Taiwan University of Science and Technology in Taiwan, and at IIT Kanpur at various positions. So, sir, we are so glad to hear with you today. Over to you, sir.
Thank you. Thank you, Niti, for nice introduction. And welcome to all participants and good afternoon to you all. So today I'm going to talk on the energy storage via batteries, which is a very burning topic nowadays. And in the background, you can see my department where I'm working with the nice salmon trees in front of that with the clear weather nowadays. So I'm very thankful to the CERT institutions, our group of institutions, for inviting me for this talk, and hope I will contribute some knowledge to you all guys. So I'm going to cover basically about the energy resources, renewable energy generation, and then why we need to store the energy, then what are the competitive technology to store the energy, then what are the selection criteria, how you select which energy device I can use at this place. And then I will give you the introduction about what is the battery and why it could be used as an energy storage device. And then how the working of the battery and basically the material part of the battery, how battery works. And then what is the reasons because of which battery fails. And then the role of carbon materials into the battery technology. Although there are so many things, but I will just focus only on one thing, carbon material. And then the green future of energy storage in Indian perspective and the world perspective. And then with some summary. So basically, if you see the energy resources available present day, we are maximally using the oil, coal, and yeah, basically we are using the coal for thermal power plants. Then for transportation, we are using the oil, and for gas system we are using for transportation also, and for electricity generation and then household things. But what is the problem with these things? Why this is called the dirty energy? The reason is that first you see it is very dangerous to the environment, because when we burn this thing, we have the output. As you can see over here is the gaseous pollutant. Thermal plant, you are getting the gaseous pollutant. So this is infecting our environment. Then the secondary products going to the water contamination. Sometimes you are drilling, you are taking the things from the earth, and then the vacant space causes the earthquake, collapsing of the mines. So many problems are there. Another problem is to the health, means when these exhausts come to the environment, this creates the headache, asthma, leukemia, means cancer, and then the cardiac problem and birth defects. But biggest problem which we are getting is the geopolitical impact, because this is always in the limited amount and it is not distributed everywhere. Like petroleum, we don't have the petroleum in Indian perspective. So you have to import, and then you have to be dependent on that company. And it takes very, very long time to replenish. Like if you want to make petroleum, it will take around 1,000 years to get it back. So non-uniform distribution causes another problem. Like if you have a dependence, then your national security is also on the risk, because if they deny to supply you the oil, you will be in problem. Another way, we have an alternate source of energy, that's called the renewable source of energy. You can say the natural form of the energy, which is which is free to us, and we have to use it by smart devices, through the smart devices. So first example is the solar, as you have heard one talk with the in this session. So he has described a lot about where we are using the photovoltaic system to convert direct sunlight into the energy. And present time, in the earth, whatever food we are eating, that is also coming from the solar. So there the plant has the efficiency of around 5% to convert the solar energy, but luckily our science has developed the solar cells, which is 20% in the efficiency, much better than the plants, and we can convert this energy and use. We have a wind. Always at the offshore, we have a wind. We can use the different type of windmills. Like here in this picture, you can see this is the bigger windmill. We have other type of windmills also, which you can install in your home, like solar cells, and you can use if you have a good wind speed annually. Then we have a hydroelectric. Again, it has the big module, small scale, and then very, very small scale hydroelectrics. So there you can generate the energy from the flowing water, which is coming from the hills to the downstream, and there in between you can put your turbine and you can use. So these two devices, wind and hydroelectric, based on the turbine to generate the electricity. Then we have a tidal energy. There also we are using the small turbines, although this use is very less in India. And we have a geothermal. We have the geothermal resources in India, but we are not using right now. So we have some hot water springs where the hot water can be used directly supplying the domestic system, or it can be used to run the turbine. And then we have a bioenergy system. It's a very diverse thing in bioenergy. We can extract the biodiesel out of that, or we can directly take our vegetable waste from the markets, and then we can convert it into the energy by controlled combustion of those things. Then we have a biogas system. So many fields are there in bioenergy. So basically, how this is going to help in fighting the climate change, because this is a big issue. As the global temperature is increasing, pollution is increasing, health is going to get deteriorated. So since these all sources produce almost no greenhouse gases, they are very diverse in energy supply. Like if you want to use the solar in your home, you can use. It's not like petroleum reserved to one place. So it's very diverse. Then it don't need, means the maintenance cost is very less. Like once you install the solar, average life, present time average life is counted to be the 40 years. So same way for the wind and hydroelectrics also. If you remove the silting problem, then even you don't need to change your turbine blades. So it's going to be very long life. So the overall cost of installation and machining going to be very down. The next benefit which we are getting out of this is the local economic development. Like if you have a solar cell, like in your house, if you have a connection of 2 kilowatts, so simply you can install the panels on your home, or like windmill, if you have a very good wind condition in your place, like if you're living in the coastal areas of India. So if you have a very good wind speed, you can use the small wind turbines, drum type, and then you can generate the energy. Now, after the 2003 energy rules in India, we can sell the energy to the grids by generating in the household, or we can use ourselves. So we have a multiple options and good things. So this could create a local job and local money also. And it's very easy to capture because the device is not complicated. Any layman, if they know, once got installed, they can use it without any problem. But what is the bad with these renewables? So the one of the worst part is this: they are the weather dependent. We are extracting the energy from the environment, so they have the dependence on the weather. Like if the sunlight is not good, like if you are a country like Norway, where nowadays it's a 22-hour sunlight, but sometimes we don't have sunlight. So in those conditions, or if you have a rainy season, so that time there is some problem with the things, and the wind speed, if it is not constant, then your windmill fails, and then sometime at the rainfall condition, it's not good. But if you do the integration, then it's a good. So if I talk about the how the renewable energy generation, so India lies quite below in per capita consumption of the energy. But if we see the how the India is adopting the renewable energy generation, it's really very impressive. So present time in the world, Norway is a country from where I am talking, is almost around 100% consumption of the renewable energy. They have 95% of the hydropower and 3.5% of the wind, and then rest of the sources they have. So this country is completely depend on the renewable sources. If we see the world average, so the world average is around 28% up to the quarter of 2020, first quarter. Although we have the corona, but still the growth is going on. So if you see the India one, so in last 5 years, India has grown 226% in installation capacity of renewable energy. It's really very impressive for the world. Even the world is, lots of articles are coming in the news in European countries about the India's growth in the renewable energies. So if we see the present time up to the June 2020, we are using 62% of the non-renewable from the coal, oil, and all those for our energy needs. And then from renewable, we are using 35.9%. So it is much above to the global electricity generation from the renewable energy. So India ranked 4th in the generation of renewable energy. After the China is on the top, and then US, and then Brazil. So basically, if we see about the energy in this bioenergy generation, this renewable energy generation, so we have majorly using the hydropower, bioenergy, wind, solar, and some other renewable sources from waste to other things. So basically, if we see the most of the energy which we are getting in India is coming from the wind and the solar. India has a quite spread coastal areas where we can use the wind turbines, and then solar, we are near the equators. That's a geopolitical benefit we have, and then we can have good things. So our increase is very good in the solar. But the problem is that these two systems are influenced by the climate. So the thing is that how to utilize these things is very important. So as per the 2018 report of Government of India, we can see still we can, in all renewable energies resources of India, we have 68.33% of the solar energy available, which we still need to explore. And in the wind, we have 27.58%, and rest of that we have some hydro and biomass and the cogeneration system. So India is still working on that. If we see the Indian GDP, because if you want to know the answer of why we need to store the energy, so this is the financial aspects of that. So India GDP, if you see with the year 2010 up to the 2019, it's increasing. Now we have 2,875 billion US dollar GDP. But what is happening with this GDP, with this money? Basically, we are importing our energy, and major imports is coming from oil and the gas, which we are using. So here is an government data of April 2020. We can see in 2013-14 we have a very high, around 140 billion US dollar we are just giving to the Middle East for purchasing our oil. Then it has gone down in 15-16 quite low, but in 18 and 20 again we have around 101 billion US dollar. You can see we are spending just to import, and this money is not small. This is going to be the 3.5 to 4% of our GDP. So if you compare with these things with the public health, we are spending just 1.28%. In education, we are maximally spending 3%. So we are spending more for the oil rather than our basic needs. So if we cut these things, we can save our money and we can use for other things. And why this is important? Because you see, these two things are very important. First thing is the 85% we are importing the oil for our vehicle, running car, scooters, and then genset. And then we have a gas for household. And everything has a solution. We can solve this problem through use of the renewable energies. Now, next is the pollution of the environment. So when we import the oil, you people are very familiar with this sticker over here, pollution under control certificate. Now government has made it very compulsory for every vehicle. Why we need to use this thing? Because we are burning the fossil fuels. So if we burn, we will get the smoke. And you can see the kind of smoke created in Delhi, you can't see even India Gate. So why this problem is coming? If we see the International Council of Clean Transportation report of 2020, we can see here the PM emissions. This PM means particulate matters, means the dust particle or small pollution particles which is coming into the air and infect our lungs. And visibility is also going down, which is creating problem in the transportation, road accidents. So many things are interlinked. So if some vehicle which is purchased before 2003, so we see the emission is going down. How long impact it has? Means it's starting from 2010 and then it's going up to the 2030. Then we have suppose we have a vehicle purchased in 2003 to 2010, the PM emission is extending up to the 2035 with the label of quite of the metric ton. If we consider from the 2010 to 2020, the vehicles purchased in this time period has the PM emission is quite high. And post 2020, if we are purchasing from today and onward, then we will have very high PM emission, because what is happening, our road transport is increasing, roads are increasing, highways are increasing, and with that our number of vehicles are also increasing. And the thing is that Indian economy is growing, so all the people are able to purchase the electric all these vehicles and the transport medium, and then it's going high. So here I'll compare the 5 major cities. It's a Terry position paper recently it came. So you see, it's a very, very surprising impact of the transportation. If you see, the transport is contributing around 50% of the air pollution in the Bangalore. In Delhi, it's less, but other industry and other products are there. So in Pune, if you see, almost 30 to 35% from the transportation. Then from industries, we are getting around 50%. So same way, you can see Kanpur and Chennai have in the range of 25 to 30% of the contribution of air pollution from your vehicle. So definitely we need not to use this dirty kind of energy. We need to use the smart way and the clean energy. Now the thing is that what we can do. So like I told you, the renewable has the weather dependent. So what you need to do, if you have extra energy, you need to store. So in good climatic condition, you can store the energy, and when the climatic condition is going bad, you have to release it. So this kind of spinning reserve, if we have, we can use in a smart way. But the thing is that how many types of energy storage systems are available, and how we can select which one we should use. So present time we have final 5 categories of the energy storage system. Like we have a mechanical storage system, where we are using basically we are using the kinetic energy and the gravitational energy to store the energy. And like in spring, if you have apply the force on the spring, it will store some energy. So this is spin for flywheel. Then we can lift the object on some height, and the when we have energy, surplus energy, and then we can release this object to the down, and it will generate the energy. Like in US, it was used from 1920s. They are taking train to the high hill height and then releasing it to get the energy back. Then we have a thermal storage. Nowadays, it's Gurgaon. We have this kind of solar plant where we are using this technology. And this plant was established with one of my teachers, and he's Professor J.K. Nayak. He's one of the leading solar thermal guy in the India. So this captures the heat, cold, and generate the energy on demand. So basically, they are using the molten salt and then converting heat in the reversible way, the molten and solid state, and then transferring the energy to the heat to water, and then from water you can run the turbine. Then pumped hydropower is another. We can when we have a surplus energy, we can pump the water to the height and then release when we don't have. And the fourth one is the hydrogen storage. What we are doing in this one, we are just splitting the water and generating the hydrogen, and it is getting stored. When we need, we can break it again by the use of fuel cell or something, and then we can get the energy. Now, the most important part is the electrochemical storage. So what we are doing in this one is basically we are applying the electricity on some chemicals which stores the energy in the form of batteries. So there are multiple type of batteries available in the market nowadays, depending on different kind of chemistry going inside the devices. So the commonly you might have seen the lead acid battery, which is very common. We can see anywhere in our household inverters, and we can see into the starting of the vehicles. We are using the lead acid battery. We have a lithium ion battery used in your mobile, nickel cadmium battery. Then we have an alkaline battery. You remember I will describe it in further. And then sodium sulfur battery is a new player in this market. Then we have a flow batteries. So flow battery is generally used at the grid, electric grid, and it's very sustainable over there. Then we have a capacitor. You might have seen this capacitor everywhere in the electronic circuit board and even in your fan also. So if I compare these 5 systems, so electrochemical energy system is very efficient. Very efficient in the response, means the point is they are very efficient because they can generate energy within seconds. While in other system, we need to have some lag time in charging and discharging. So what could be the selection criteria? So for selection criteria, first we have to know about the basic component of the energy storage devices. So basically, we have major 4 components in the energy storage devices. So first thing is the storage medium. So like storage medium in mechanical spring, you have the spring. In hydro, you have a water. Then if you go to the electrochemical system, batteries, you have an electrolyte, you have a cathode, anode. So everywhere you have a solid medium in some substance. Then we have a charging system. Charging system means by which we can introduce the energy. Means this is the source of energy, the pathway of energy by which we can introduce that energy into the medium. Then we have a discharging system. Means the way how we can remove or extract the energy from the stored device. And then we have a controlling system, means how we can control. In a controlled way we can give the energy, and in a controlled way we can remove the energy out of that system. So these 4 criteria are very important when you're selecting, because these are the responsible thing for the pricing, sustainability. So many things are there. So first thing is the load management, like load leveling and load following. What amount of energy you need, what amount of energy you have to store, and what are the surplus things, how many, means what is the dependence of these surplus things on the timeline of the month, year, week or day. Accordingly, we check this thing. Then is the technical maturity, means like if you are using some devices, so is this device efficiency is very good, or the device is very sustainable, or the device is very perfect, it is very cheap to implement. Then we see the environmental impact, basically the visual impact, how it is, then biological, then greenhouse emission. So generally with the renewables, we don't have this problem, except to the bioenergy, where we have some issues with the emissions. Then we have a power quality, means how much energy it can store with the volume or with the weight. So this is very important. And how efficient it is able to remove the energy. Then we have a quantitative criteria like power density, energy density, then the efficiency of device, and the most important part is the cost. Because like lithium-ion battery, we can't put into the running car, because still it's expensive. Although the price has gone too much down in last 5 years, is 1/3 of the price has slashed, but lithium is still is a limitations. So the cost is very important. As I told you in the previous slide, in the grid system, we are using the flow batteries, because flow batteries are very cheap and it has a very, very long time in compared to the any kind of batteries. If you see the lead acid or the lithium ion. So that's why it is used there. Now, why we should select battery as energy storage devices? So battery has several benefits. So one of the benefit we can see it can be deployed at the electricity generation level. Like if you have a solar panel, or like in your home also you are using the UPS, you are just storing the energy into the battery. So your inverter in the home is using a lead acid battery, but it can be different batteries also, not only the lead acid. Then it could help in the transmission distribution, like if you have a powerhouse and there, because of sometime we have a load up and load down because of the availability of water or the cleaning or something in the system, in the small hydro or medium hydro. So there also we can use it, and then we can manage the fluctuality in the power supply. Then battery have a range of energy density and the power selection. So if you have any device which has a very diverse in the energy density, in the potential operations, then you can easily select, okay, for the power system we can use this one, for solar system we can use this one, and for transportation we can use this one. So battery can solve the inconsistent supply energy problem, and is directly get the energy from the renewable. Then it's really very, very cheap. And then battery are compatible with the almost all renewable energy generations. So as I showed in the first cycle, second slide, almost all everywhere we can use the batteries to store the energy generated by those resources. And it could be a very good energy mixer. Like if you are generating some energy from the solar panel and then generating something from the wind, and then you can store both energy into the same device. And then you can supply whenever it is needed. So if you use at the power plant, so it could avoid the frequency fluctuation instability during the low setting and high demand. Then could be a very good spinning reserve, means it can store the extra energy, and when it is needed it can release. So by this way you can see this, the batteries can be used on grid in your power generation system, power storage system, and then it could be used at your household, means off grid also. So it's why it is, because it's a good load leveling property. And one of the most beneficial part of the battery is that if you want to install a battery, you don't need any extra infrastructure. You just need a battery, a packed battery which is coming from industry. You just connect and use. And then the environmental risk is very low. Like it is not going to explode at your working place if you are using under controlled condition. And it's very environmental friendly because it's not releasing any kind of gas or any kind of pollutant into your installation place. So these are very good benefit of the battery, because of which the world is now looking toward the battery to implement everywhere. Everywhere means you can see the avionics we are trying. You might have listened one project from the global aviation. One flight has started from US, and it completed one complete circle of the earth using just solar panel and batteries. Even in the present time, for battery backup, we are using energy backup in the flights, we are using the batteries. And in satellite also, we are using the batteries to do all kind of missions on the Mars, like your rover and everything is running there. It's just stored energy over there inside this one. We have a battery in the missile technology to guide it. Then we have a batteries in our household, transportation, everywhere we are using the batteries. Even in the medical system, if you see, we have the heart pacemaker there, we are using the batteries. So almost everywhere the battery's importance is increasing. And the biggest thing, if you want to check about the use of battery, you just check your mobile phone and laptops. So this is also running on the batteries. Now the thing is, the interesting part about the history of the battery, how the battery was developed. So history is very contradicting in the always with the evidences. So present time science is showing that battery was discovered in 1800th century in Italy by Volta. So you can see his device, this Volta pile. It is his own device. It's image from one museum I took from their website. So this is exactly the same battery. They use the zinc and copper plates separated with the one separator with some salt, wet electrolyte, and then they are getting some amount of energy out of that. But before that, there is an archaeological evidence, and this is called the Baghdad battery. You can see in this side where my cursor is there. So this has been found in the archaeological survey exploration in the Baghdad, Iraq, present time Iraq. That time it was the Mesopotamian civilization. So in that battery, it's an earthen pot, and they are filling the grape juice inside, and then they are putting the copper. It is inlined with the copper, and they have the iron things. So this kind of battery was found over there. But you can think what kind of use they are doing, because there was no bulb at that time. So it was predicted by the archaeological historians that they are using this for the punishment. So they are giving punishment by the electric shock, the small electric shock which they are getting out of this, are combining the cells. But officially, this is accepted, Volta's, and Volta is considered to be the father of this battery discovery. That's why we have a Volt unit. Then the Daniel cell was discovered, where we have two different solutions, and with the different electrodes, zinc and carbon, connected with the salt bridge. And then we have some solution like 10th class, our electrochemistry things. Then we have a Leclanche cell, which is in dry state. And then it used the manganese oxide as a cathode, zinc as an anode, and then carbon as a current collector, and ammonium chloride as an electrolyte. And then the alkaline battery has come. We might have seen this thing in our childhood, and some people have not seen yet if they are very young. So this is alkaline battery, where they have used the nickel cadmium, and this Leclanche cell was also commercialized sometime, and it was in the market. So this Eveready is the battery manufacturing company, and we can see this oldest battery manufacturing company in the India still now. So, but they are working on the old technology. And then we have a lithium ion battery. So this is most powerful because this is working on the potential 3.2 volt to 3.7 volt, while rest of these batteries in the range of 1.2 to 1 volt. So the potential of battery is very important. I will describe later on. So what we are doing, basically, this is the old technology in the new formulation, because when we don't have the petroleum, we are using battery for electric vehicle. But now we are going back again. So here I'll explain how the battery works. So there are multiple type of batteries, but I'll not go in everything in very detail, but I'll see you the very basic things, how battery works basically. So generally, if you take from the previous slide, we have 2 electrodes and 1 electrolyte. So these are basic component of battery. You must have a cathode, you must have an anode, and then you have an electrolyte, and then you have a separation medium for them. So that is called separation medium, is called the separator. You have a cathode, and then you have an anode. Means one place you are performing the oxidation reaction, another place you are performing the reduction reaction. And what is happening with this one, the ions are moving. Basically, these are the charged ion. When they are in the crystal, they are neutral. When they are coming out of the crystal, they are in the charge form. So basically, the cathode and anodes are electronic transporter, because when this ion are created, the electrons are getting transferred to the current collector, and then we are going to get into the device. This electrolyte which we are using is the ionic transportation. Means the ions released from the cathode or anode, it's coming and passing through the electrolyte. So the another role of electrolyte, it don't allow the short circuit of the cathode and anode, means positive or negative terminals of them. Then we have something called solid electrolyte interface. This is not the topic of this one, although this is my expertise in research. So next we have a lithium air battery. This is nowadays lots of money is coming in this lithium air battery, because this is looked for the future of the electric vehicle and transportation, because it has very huge energy density. So in this one we are using the lithium Basically, this is a mixture of the battery and the fuel cell. So what we are doing in this one, we are using the lithium as an anode, pure lithium metal. And then we are using the separator. We have some electrolyte in first chamber, then we have some electrolyte with the catalyst and carbon in the second chamber. So what we are doing, we are basically taking the oxygen reduction reaction and converting lithium into the lithium oxide and then again coming back. So this way we are generating the energy, and the energy density is very, very high compared to the any kind of battery system. In the flow battery, this is not very competitive with the term of energy density, but with the life cycle, it is very, very competitive. That's why it is used as a grid system. So, and this is not practical to use in the home also, because you need a particularly centralized installation. You can't do the decentralized installation. While with these two battery systems, lithium air and lithium ion battery, you can do the decentralized installation. In this one, you have two bigger tanks, and these two tanks has some chemicals, which is electrolyte, and one tank is playing role for the oxidation, another tank is playing role for the reduction, and then it's going through some fuel cell and generating the energy. So this is very good because the life cycle is very good. In these two cells, if you see lithium ion battery and lithium air battery, once your electrodes has certain life, it's over. Then you have to dismantle the device and you have to refabricate. Means you have to replace the device. But in this one, you don't have to change the device. You just need to change the liquid present in these two chambers, and then it's again new. So that's why it is preferred to use at the grid locations where you want to save. Although the potential is very less, it's just 1.2 volt to 3 volt, while this one is above to the 3 volt to going up to the 5 volt also. So, so depending on the location, we are using the battery. Now, how we select the electrode? So this is very important criteria when you're selecting any battery and for the application. Like in lead acid battery, it's very common to use nowadays in our cars, in households, everywhere we are using, because it's very cheap. But it's very dangerous actually, because we are using the lead, and lead is very poisonous to the health. Or in the nickel cadmium, we are using the cadmium, which is causing the blood cancer. So recycling has the problem. Although the pack don't have any issue, but when you recycle this battery, has the issues. But another problem which is coming is the energy density. Energy density means, like if you take 1 kg of battery, how much energy you are able to extract, how many watt hours you are able to extract, basically. So the lead acid battery lies very, very below. It's just around 100. So if you are spending some money for this lead acid battery, so one way you are getting loss in the weight, you have to add more weight and get less energy, and you are spending money already. So we have other technologies like lithium metal hydride, lithium ion battery, and lithium metal unsafe. Lithium metal battery, although now it's not unsafe. Lots of research is coming nowadays, and then we have a new Apple iPhone coming with the lithium metal battery only. So this has a very high energy density, around more than the 350 watt hour per kg per liter, and energy density, if you take by the weight, it's coming around 200 to 225. So what are the techniques to, and these are very dependent on the potential of the cell, because these two things are very important. If you want to enhance the energy density of the cell, these two things are very important. Means what kind of potential you are able to extract from your cell, and how much energy you can store into the cell. So these two things are very important, because if you multiply voltage with the capacity, you get the power of the cell. So the thing which is coming from the very basic 10th class chemistry is the electrochemical series. So you can see the reduction potential is very high for the lithium. It is around 3.05 volt. And with respect to this, if you use any metal, you can directly do the simple maths, and you can count the cell potential. Like if you are using the against to the hydrogen, which is 0, so the cell potential will go to the 3.5. So same way we have using this iron, then the cell potential is going to be the 3. Your cell potential will be the 2.5 around. So basically what is happening, we are selecting out of this. Then we have other form of compound, because this is just for the element. We have compounds also where you can get very high potential. So in present time in lithium, we can reach up to the 5 volt in lithium-ion battery using some special nickel compounds, and then we can go up to the 5 volt. So one way you can increase the energy density is the potential. Second is the capacity. So you can change the charge storing capacity by changing the material. So I'll explain for the cycle how it is enhancing. Now, the thing is that in previous slide, I showed you the schemes of the battery, but how real battery looks. So when we go into the market, we are seeing the battery in the button type like this. We are seeing the cylinder 18650 it is called in technical terms, but basically this is like a cylindrical cell which we are using. So these are the same, any kind of battery like nickel metal hydride or not the lead acid, but other dry batteries like your nickel metal hydride, nickel cadmium battery or alkaline cell, all can be packed in this kind of forms. So if it is the length is high and then diameter is less, then it is called the cylindrical type of cell. And basically it has the different component, like we have a separator, I explained in the previous slide. Then we have a cathode, anode, then supported with certain kind of current collector like copper and aluminum. And then we have some electrolyte, and then we have a can, basically the metallic can, which we can see when we are going into the market. Battery is always packed into the metallic can just for the safety. But we have two other types, which is particularly used for the large scale application. These are for house scale application, button cell, and then this cylindrical cell. We have, this is called the prismatic cell. You might have seen your old batteries of your mobile. Nowadays you can't see, but it's the same kind of thing in laptop and in the mobile. We are using the prismatic cell. And then we have this pouch cell. This is a very flexible. We are not using any metal into this one. So it's just an polymer, and the whole battery component is sealed into this one, into this, and then we are making the battery pack, and then finally the battery pack has the plastic covering or the metallic covering. So these are the basic component, means how they are assembling. If I go into detail, it will again take too much time. What are the technical things into this one? So generally we have the positive terminal, negative terminal, and insulating body. So in every one, positive, negative, and for cathode and anode. Now, what is the reason the battery get failed? So this is a very old research by one Japanese group, because Japanese were the first who discovered the lithium-ion reversible battery. So we have basically, I have forgot to explain there, we have a two kind of battery. One battery which we are using and just throwing, and another battery we have which we are recharging. So example is like your torch battery. So torch battery you are using and just throwing, and you have a mobile battery or laptop battery, you are recharging again and again. Once get discharged, you are recharging. So this is called reversible battery. So in reversible battery, you might remember when we are getting the Nokia phone, and then we have some cell which we can take out. So people are saying, oh, just rotate the cell on the table, and then if it is rotating, then spinning very freely, then your battery has gone. So what is the reason? You can see in this picture. In present time battery chemistry, which we are using, we are generating some gases inside the battery because of the reaction, because of some internal heat generation inside the battery, because it's working on very high potential, and then electrolyte is not very suitable. So those gases which generated inside the cell, although it's very small, but with the number of cycle, it creates the swelling inside the cell. And when this swelling is increases, it just explodes. You can see over here, it's exploding. And the gases which is coming out of this cells, especially this is case of the lithium-ion battery, when it is coming out, these are very combustible gases. These are ethane, methane. So these used to burn with the local heat available over there. So for this one, we have an engineering solution for the batteries. That's called the battery management system. It's a complete branch in the battery. So I'm not going to cover, but just I'll give a very, very little introduction about the battery management system. When you are going to use the battery, we used to have some kind of management to have for the safety of this high energy batteries, high energy density batteries. So first thing, we are looking for the state of health. State of health means, like if you have battery and it has a 200 watt hour kg capacity. So once you use, with the time, the battery will degrade. In layman language, if I say, like you have a mobile device, and that has a lithium-ion battery, So when you purchase the mobile, that time, once you charge, it end up the charge into the 12-hour or 24 hours of operations. Nowadays, it's possible with the 300 mAh battery. But what is happening when you use for 1 month, 2 months, 3 months, 6 months, after 6 months, what you will notice that once you charge, the battery is giving you only for 15 hour or 12 hour. So what is happening? It's losing its health. Basically, it's losing its capacity in technical term. So the amount of energy stored, it's losing. So we have to see about the technology or the material which we are using inside the battery, what kind of application is there and what kind of material we should use. So that way we can monitor the state of health of the battery. Then second is the depth of discharge and state of charge. This is very important technically when we are implementing the battery. We have an electronic circuit over there in the devices, like in mobile, you have lots of apps coming with the energy saver or energy booster. So these apps, what they are doing, they are basically maintaining the depth of discharge, means how much lower you can go into the discharge, how much, like a battery has the capacity 3000 mAh. So out of 3000 mAh, how much you are using? Is 80% or 90%, that's called the depth of discharge. And when you are charging, how much you are charging? Means you are charging 100%, 90%, because if I go into deep, there are lots of material science into that, why we are selecting this kind of electronic parameters in the battery management system. So I told you this is a very, very large field, and it could have a very different talk, not in this one. So the question comes, why battery fails? So one reason I have told you about the gas evolution inside the battery. But here is a flow diagram from my side, and I can show you some pictures over here. Like you have heard the news about the 787 Dreamliner. This battery has failed, and then the new model from the avionic company has to ground it. So why they have grounded? Because battery has failed to support their system, and there is a fire chances over there. So if there is a fire, the chances is very less to save. So Boeing has planned to dismantle that battery. Then we have lots of cases. We can get the internet picture in this one. Mobile burning, like you should not charge the mobile when it is in use. In laptop burning, these kind of problems are there nowadays. It's not common. The most important is here is the example of Fukushima. It's recently the explosion happened in a nuclear reactor of the Japan in Fukushima. And why it has failed? Because safety mechanism has failed. And why safety mechanism has failed? Because when they have to insert the rods to absorb the neutron, those things were supported first by electricity, second by genset, third by the batteries. So what happened? Because of the tsunami, water has entered into the power plant, and because of that, the temperature has increased and the reactor chamber has exploded, and because of that, the water has came to the genset system. Then people have tried to use the battery, and the battery unit also got submerged into the water. So they don't have the perfect water insulation for the batteries, and then the rod was not inserted, and then it exploded like anything. So basically, those are the system level things. But what is happening inside the battery? So basic cause of the battery failure is the heat generation. Practically, if you see in your home or if you're charging your mobile, you just touch the back part of the battery. It's heating when you're charging. Or if you are using very high application, sometimes heat is there when we are draining the current at very high rate. So generally we have a two kind of heat generated inside the battery. One is the reversible heat. This reversible heat coming from the electrochemical reactions in the cell. Like when ions are moving from one direction to the another direction, it's generating some kind of energy. So generally it's not in our control how to control those things. Then we have a irreversible heat. Irreversible heat is coming again with the certain parameters of the cell. And those parameters are ohmic resistance, like we can say the V is equal to when we are comparing this. So the resistance felt by the electron transport inside the battery cathode and the anode, that's called the ohmic resistance. Then we have a polarization, because when ions try to come out of that, because of the free energy issues which is required to move the ions into the electrolyte, and then the problem at the interface. This polarization is increasing. This is also contributing to the energy. This is also kind of a resistance, but it's fully faced by the ions. And then we have a certain side reactions. Basically, some component in the battery, when you use, it's reacting because it's a very high potential. Like if you have a nickel battery, nickel-based lithium-ion battery, so generally it works above to the 4 volt, and our electrolyte is not supporting. Present time electrolyte is not supporting to the 4 volt. So we have certain kind of reactions at the interface. That's called the side reaction. It's a full of. I'm not going to go into detail. Just give you an example. So these three things contribute to the internal resistance of the cell, and internal resistance always contribute to the heating because it generates some local heat. So generally, if you have a bad device, it will have more resistance, and this will cause the burning. This is the major problem actually. So when we are industrially trying to design any battery, we are looking for these internal parameters. Then we have battery management. Again, I will elaborate how you can minimize the previous things. So we have, like if you want to minimize the heat generation into the cell, we have two approaches. One you can do at the pack level, and one you can do at the cell level. So basically, what is the cell and what is the pack? Cell, where we have one electrode called cathode, another electrode called anode, combined with the electrolyte, that's called a single cell. When you mix several cells, it's called the batteries. And when you mix several batteries into a certain needs, that's called the pack level. So in pack level management, we can do this kind of management. Like if you have a heating, you can do the thermal management, active or passive cooling over there by using mechanical fans. Or you can do the electronic things over there in pack level, like if you're using the batteries into some high power applications, like in trains or in electrics. So you can use avoid the short circuit, then over voltaging, then thermal cutoff. Means like if battery is heated up to this point, you just stop the part of battery to use. So this kind of management you can do at the pack level. Then if you go at the cell level, what you can do, you can change the cell design. You can change the cell chemistry. Because I told you there is a huge potential range is available for the batteries. Then you can change the electrolyte. In electrolytes and in the cathode, we have the additives, which used to cut up the circuit where there are certain chemical compounds, like if you add into that one, it will not allow the battery to go beyond to the 4 volt. Then we have cathode and anodes. Depending on that, as I showed you in the electrochemical series, you can select the cathode and anode accordingly, you will get the potential out of that. Then in cell design, you can do the postal thermal coefficient device. Then you can use the ceramic material, conductive polymers. Then we have a safety circuit, safety vents. If you have some gas things are there, you can use the safety vents inside the cell and it will release the gas and safely you can take it out of the system. Then you shut down and then you can use the separator. Then you can do certain kind of electrode coating to protect the cell. These are deep material science. I'm not going to describe how it is working. Now here I'll give you some role of carbon materials inside the battery. So what I'm going to explain now is about the material science of the battery, basically. So how you tune the cathode and anodes. So I will just explain about the carbon. Why the only carbon? We have several materials, but first battery, reversible battery, which is commercialized by the Sony, Japan company of Japan. They use the carbon as an anode. So anode is a place where the lithiums are coming out of the system and getting stored when you are charging the battery. When you discharge, the lithium is going out. So basically what we can do, like here, I have an example of tin sulfide. Tin sulfide is used in the battery anode. Basically in the cameras, when you have a low temperature operations, tin is used. Because generally graphite bed battery don't work if you are going to the temperature 4 or 5 degrees centigrade, this battery fails because their kinetics, internal kinetics is dependent on the temperature. So tin is used. Tin is very feasible in those ranges. So here is one of my research work. We have used 3 kind of carbons. Basically some spherical carbon. Then we coated the particles with the carbon, and then we have a graphene, which is a 2-dimensional sheet. So here you can see the TM image. The particle is coated with the carbon. This is 5 nanometer carbon coated on the surface. And then it is the graphene surface supported with the tin. particles. So what is happening with this one? Basically, why we are using the carbon? One is it stores the lithium. Second is that it works as a electron conducting medium inside the electrode. Like if some reactions is there for lithium with the tin, then the electron removed is going through this carbon material to the current collector, and then finally we are getting out of the terminals. So here is the charge and discharge capacity of this cell, comparing this carbon, all three kind of carbons. So you see in the first cycle, we are getting around 1800 milliamps per gram. In initial cycle, we have the losses. As I explained in my previous cycle, we have lots of side reactions, lots of things in the initial cycle. So when you get the product in the market, it is already activated. Generally in research level, we don't talk about the activation. But in industrial product, we have an activated cell. Already when you purchase the cell, you will find the potential. If you measure with the multimeter, you will find around 2.5 volt or 2 volt for the lithium, although their potential is around 3.7. So it's already pre-activated, means these losses are already managed inside the cell. But with the cycle life, you can see with each cycle number, the capacity is decreasing. So here is the pure graphite. You see the pure graphite is giving around 175 milliamps hour per gram, very constant. It's very good. That's why first time it was used in the battery, but it lacks the amount of energy it stores. It's very less in compared to the tin, if you see. But the tin, it's increasing. So we can see here the difference with the, if we use the normal carbon. So with normal carbon, you see the trend is decreasing. With the carbon coated system, it's also losing. But when graphene was used, just the amount of the carbon was changed, everything was same. Then it get stabilized, and we are getting around 900 milliamps hour. Means 4 or 5 times higher than the normal graphite. So this way means we can select the material, we can select the component of the electrode, and then we can increase the amount of charge stored inside the battery. Now here I'll show you one post-mortem analysis of the battery. Post-mortem analysis means you use the battery and then you disassemble and you see what happened to their electrodes. So basically this is a curve, this is the voltage and versus the time. So the battery was discharged from 3 volt to the 0 volt, 0.01 volt actually. And it's a scientific test, not the practical test. And then it is again charged. So we have seen these are our first electrode material. These are the graphene supported with the nanoparticles of the tin. When it was lithiated, when lithium has started going inside this one, so generally one tin particle used to take 4 lithium, means you can count the volume will increase. So we can see over here at the point B, over here, the particle size, which is in nanometer, is increased into the hundreds of the nanometer. And when we start removing lithium, then the particle shrinks. But you see the distribution is very good on this surface. So these are basically the, and when we completely remove the lithium, we still have a very good particle. But when the spherical carbon, as I showed in my previous slide, the particles were expand in very different way. Means some particle remain crystalline, some particle is going into the amorphous phase. So if it is amorphous, it don't react with the lithium. If it is a crystalline bigger size, it reacts. So we can clearly see in the post-mortem analysis, dismantle cell under the transmission electron microscopy, that if we have a two-dimensional carbon, it supports very well to the particles and give you a very nice performance. And this increases the life cycle of the cell. So this Next-Leon battery, which is used in the Sony cameras for low temperature operations, uses this kind of things, carbon-based, with the different composites. Here in my research, I saw this, if you replace the carbon and then you use the graphene, it could be a very better result. Now, another application of carbon I will show in the modern batteries, and this is the sulfur battery basically. So sulfur battery has the compromised potential in compared to the lithium ion battery, because in lithium ion battery, I told you can get starting from 3.5 volt going to up to the 5 volt. But in sulfur battery, you will compromise with the potential. So the potential will be, the cell potential will be around 2.2 to 2.5 volt maximum. And but the benefit you will get, you can store lots of energy. So like I told you, if you multiply voltage with the capacity, you get the power of the cell, the energy density of the cell, with the taking weight into consideration. So in this one, you can store 10 times more energy in compared to the any lithium ion battery system. which I explained previously. So that's why nowadays it is looked for the electric vehicle. So if we talk about the energy density term, lithium-ion battery maximum can go 250 to 200 around watt hour per kg. But in sulfur battery, still it's in developmental stage. Some companies is commercializing also. So this can give you 400 watt hour, means almost double capacity of the lithium-ion battery. This also has the lithium, but this is called the lithium sulfur battery, or commonly called the sulfur battery. So here is our one research where we have used the carbon, and in carbon we impregnated the sulfur, and then it was supported with the graphene. So what we find, if we don't have these things, the carbon and other things, so it is losing the capacity. And this is 500 cycles of the run. And when we use the carbon and graphene both together, the stability is very good. We are getting 800 milliamps hour stable capacity up to the 500 cycle, and it's go. And if you see the talking about the Coulombic efficiency term, means the energy you given to the system and extracted from the system is almost 100%. So this is showing the system is very, very good, and it can go more than 1,000, 2,000 cycles. So this is a very potential technology, and this has the future. This can replace the one application in the electric vehicle side, not in your mobile applications. You always need use your apps, too many apps at a time. So you need the lithium-ion battery only over there. Here is one of my research when I was in US. So this is called the thin film battery. So basically like in electronic boards or some small devices, actuators, sensors, you need a very small size of battery. So there you need to have some thin film batteries. So thin film battery generally has the less energy density. Here what we showed over here, you can make the battery without using any kind of carbon. Means generally a battery electrode has three components. One is your active material, which is reacting with the lithium. Another is your carbon, which conducts the electron. And third thing is the binder, which used to make for the film. So without using any binder or any film, you just deposit the nanocrystalline titanium oxide on the current collector, simply like in this cell setup. This is coin cell setup, the button cell. So we grown the this TiO2 crystals, which is working as an anode, and then we can use the separator, and on top of that we can use the anode, the cathode. And we can see over here, up to the 100 cycle we have without loss, 100 milliamps hour per capacity. This is half cell data, and 1C we are getting around 200 at 1C. 1C means this is a kind of technical rating which in industry we are using to test any battery. So once the C rating means like if you are charging your battery in 1 hour and removing all the charge into the 1 hour, that's called the 1C. So like here, if you're going 2C means you are giving charge into the half hour and then removing your charge into the half hour. So like 10C. So basically you are going to give charge everything in very, very short time. So even that time also it's very stable. So like for electronic devices, these kind of thin film batteries are very good. Now I have explained everything about the battery, how battery fails, what are the battery things, but we have to see how the industry and governments are looking toward this technology and the feasibility of this system in present time needs of the world. So as I explained, these batteries can be used at the grid level, off grid level, and this can solve our pollution problem, economic problem, geopolitical problem. There are lots of problems can be solved with use of this energy storage devices. So here I'll take the example and comparing the India's approach with the world. So if you see the world, so world has decided one thing, because we recently have the Paris climate deal. You might have heard about these things. So Paris climate deal is to save our planet Earth, and to save this planet we have to have some alternate source of energy. So the whole world has divided to full transition of electric drive, means the transportation part we have to cut it down. So from 2025 to 2050, these countries, France, Germany, India, Netherlands, Norway, and United Kingdom, has decided to cut gasoline means petrol and diesel based electric vehicle, and completely come on the electric vehicle, no hybrid, nothing, just electric. So here is a term, here is a graph. Here we can see this is the projection of different countries with the years, how they are going to meet this demand. So you see this curve is for Norway, where I am speaking now. And this is the country where I rarely see any oil-based, means gasoline-based car. Most of the car is the electric, and every household they are charging, and then they have all kind of charging stations. So the Norway is the highest in the world to use the electric car. I told you another benefit, they are using around 100% of the energy from the renewable sources. So their electricity is very financially feasible as per the income of this country. Then we have second Netherlands, which is again another Scandinavian country. And then UK, France, Germany. So you can see all the Western country, developed country, they are using the electric vehicle just to save the environment, save the petrol money, which is going out of the country. Although the Norway is a petroleum country, it's Saudi Arabia of the Europe, but even they are producing the oil. They are the fourth largest producer of the oil, but still they are not using their oil. They are exporting, and then they are using electric vehicle. So European Union has the target of 2020 target, in which they decided that they are going to cut 20% of the greenhouse gas from the level of 1990. Then they are going to get the energy from the renewables, and then 20% improvement in the energy efficiency. Energy efficiency means like in India, we have a program to change our simple tungsten bulb from tungsten bulb to the LED bulb. So what we want to do, we just want to increase our energy efficiency of household energy consumption, because LEDs are more efficient. Their luminosity is very high, flux density is very high in compared to the tungsten based cell. And another approach, if you see from the India, just one example I have given from the NDD. Another approach, if you see, India is signatory of the Paris Climate Deal, and we are very much devoted. So we are going toward that. We have lots of pollution problem in India, but it's not like that. We are decided and we are working on this. So we have a national mission of electric mobility, which was proposed in 2011. Then it was modified. Again, another mission has came, and the plan 2020 has came. Although it's going on, not yet fully achieved mission, but yes, we are achieving lots of things into that. Now, present time, we have three major things. The FAME India 2015, you can visit the site of these things, and it's really very inspiring. The people can support to the government and then get a better result. So in this FAME India, what this has the two phases, phase 1 and phase 2. Phase 1 is over, phase 2 is going on. So in that one, we are doing the faster adoption for manufacturing of hybrid electric vehicle. Now is hybrid has gone, is pure electric in phase 2. And there are several things how we are selecting the electric vehicle. But in Indian geographical condition, mostly we need the pure electric is okay for us. We don't need the hybrid. And then we have a campaign EV30. It's run by these major countries: France, Germany, India, Netherlands, Norway, and United Kingdom. So EV30 has the target to cut the 30% sales share of the increase the 30% share into all the transportation and of the electric vehicle. And then we have a national smart grid mission 2014 to 20. Still this mission is going on. So they have one column especially focused on the electric vehicle charging station development and the charge storage system. So basically to develop some infrastructure, battery manufacturing companies, promote the electric things, and then develop the charging station. Because once you change your vehicle from the gasoline based to the electric, you need to charge the battery. So you need to have the charging stations like petrol pumps. Now here is the one news article where our railway minister is saying on the 12th July 20 in Economic Times, by 2030 India hopes the world's first 100% green railway with net zero emission. So what they are going to do, they are going to use the solar panels, they are using to have the batteries. And recently I have a talk with the one French-based company. They got the contract in India. They opened the factory up also in the India, especially for the railways. So basically you can see there is no diesel engine now. electric engine, and we know the electric engine always has the plus point over your combustion based engine because of the better torque we are getting into the electric. Now, I showed you some planning on the implementation. Now, on the controlling side, if you see our Pollution Control Board of India, they also active from 2010. So they have implemented the rule, Battery Management and Handling Amendment Rule. You can go to this site, Central Pollution Control Board site, and you can find their implementation, the rules they have used for the recycling of the battery. But this is particularly for the lead acid battery. For other batteries, they also have to make the rules. So they are focusing on the lead acid battery used in automotive, four-wheelers, two-wheelers, industrial, UPS, motive powers, and standby and others inverters like. So how to make the battery, what kind of safety you have to take, and how you have to dispose it, how you recycle it, these kind of controlled by the Central Pollution Board. But why we should use the green mobility? This is a big question. So I have introduced in the previous 3 slides the financial reason, how much money we are spending to the oil producing country. Second is the pollution which we are creating because of the transportation, around 50% in our major cities. Third reason I have given about the use of better use of the electricity generated from the renewables. So what we can do with this one, these devices are very much electric efficient. Why? Because we are using the electric engine. And electric engine, it's very well known that electric engine efficiency is more than 90% in compared to the combustion engine, which is limited with the thermodynamics with the 32%. Accidental safety is very good in the electric vehicle. Why? Because if your car get accident with the petrol tank can blast. But with the batteries, these chances are very, very less because most of the parts are solid. So the spread of fuel is not there. Multiple refueling point charging. So like in petrol vehicle, we need to go to the petrol pump. But with the electric vehicle, you need not to go anywhere. You just go to your office. You just plug in. Like in Norway, I can see the people are just plugging into the office, and with the app, they can monitor sitting in their office how much battery was charged, and then they can disconnect. So it's all digital. Now you can recharge your cell into your home also. Just in night time you can put it. And now you can see in our city transportation there are some rickshaws, auto rickshaws based on the batteries. Now it's in use in the India. And then the maintenance cost is very less because like if you have a lead acid battery, you just have to add some water as an electrolyte to when it is getting decomposed. In lithium ion battery, you don't need to add anything in its life cycle. So generally it's a 2000 cycle. So it's too much for you in present application. And the cheaper fuel cost. If you compare the cost of the electricity to charge the battery in the transportation with the current oil prices, it's going to be much cheaper. And I will give example from our recent developments. And there is no emission. So generally, the battery-based electric system don't produce any kind of exhaust. So what exhaust we are getting when we are making the battery? Like some battery components are made and then we are spending some energy over there, and then some effluents are coming out of that. So that is only there. That's called the secondary effluent. But primarily, you are not going to remove any kind of exhaust. So here is the development from the Hero cycles, Hero motorcycles, and they developed the scooties. Now it's in the Indian market. And then Mahindra has came really very fantastic job done by the Mahindra group. They have developed range of things. So they collaborated with the Ola. So Ola is going to be with this ME model you can see over here with all Ola vehicles going to be the electric. So one way the public transportation is going to be the electric. I told you another way the rickshaw which we are using with the battery operated. Although the speed is less, we can improve it with the battery management system in the future. And then here you can see the public transportation for a small level of cargoes. And this is for the public means personal family life transportation. So they have the electric car. So here is one specification for those batteries. These batteries, basically, you see this model is E2O plus. And the specification, if you see, this run at the cost of 80 paise per kilometer. Super cheap. If you count the present present petroleum cost, you are purchasing the petrol from 75 to 80 rupees. So you just calculate the average and how much rupees you are spending for per kilometer run of your car is going to be 3 to 4 rupees. But electric car is giving just 80 paise per kilometer. So it's super cheap. The drawback present time is the charging time. So if you want to charge as per this model, P6 model, it's going to take 6 hours if you are using the 3 kilowatt charger with 16 ampere current. You can go faster also, but I don't suggest to go for the faster charging because it compromises with the life of your battery. Generally nowadays, this thing is coming with your mobile phones also. There are some apps which do the faster charging, but it's not good for the health of battery. But in night time, you can just put your this electric car for the charging, and morning you can use. So generally in one charge, it's running around 140 kilometers. So it's enough for your city applications. While this is the Mahindra's one, but in Norway, a common car can run up to 350 kilometers just by one charge. So here we have some companies from the Tesla and others. So they have a better batteries. Since India don't have any battery manufacturing, especially in the lithium ion, so we are importing, and then we have compromised with this one. So the battery capacity which they have used is 210 ampere hour. And most important thing is that another drawback nowadays is the battery weight. Because if our battery is very heavy, like in this case, it is 84 kg of the battery. So it's covering around 9% of the crib weight of the vehicle. So this is also used. If you compare this weight with the petrol which you are using into the system, it's very less. So petrol weight, like if you 15 liter of petrol, so it's going to be very lighter, less than the 15 kg. So the thing is that here the weight you are giving, but the thing is that the benefit we are getting over here in the cost. So this can be improved with the new technologies. We are still doing research on this one, and I know this can be very less. This sharing of the crib weight can be very less. It could be reduced from 9% to the 5% also. It's possible. So there are lots of engineering solutions are going on in the battery field, and the whole world is looking toward the electric vehicle, and lots of countries are implementing, although the Norway is highest. So I just like to summarize this my talk for today. So India has immense potential for the clean energy generation through the renewables and store it to make a better integrations. And if you want to save your foreign exchange, which you're expending into the importing oil and gas, you want to save your environment, and you want to be the Atmanirbhar in energy sense. So you must have to deploy and utilize the energy in a very smart way, using smart energy systems, efficient devices, and then integration of different devices through the energy storage. So batteries is your present energy wallet. Like you can store the energy, like you are storing your money inside your wallet, like Paytm or in your physical things, and just you took it. If you want to check your wallet, just check your laptop. You can charge the laptop with the mobile with the laptop, depending on the device in between which you are using, or different kind of battery things you can use. So it's kind of energy wallet. You can give and take the energy, money of energy. Battery has a wide field of applications from power plant, distribution, and small scale electronics. Then design, assembly, and battery management system. These are three major core systems nowadays. Lots of scientists are looking in different parts with their capabilities and then improving the energy system. That's why I told you in last 10 years, the battery cost has gone around 1/3 down. So it's a very good development in the field of batteries. And carbon has immense role to play, and carbon we can easily make. Means with the natural products we can make, because our body and all the environment is made of carbon. So it's very easy to make the battery based carbon. And recently I have a talk with discussion with one of the battery carbon company in the Bhopal, and they have successfully made their carbon for use in batteries. It's really impressive development in India. All kind of industries are looking toward the batteries, and battery has to play many pivotal role in development of sustainable growth. So it's very clear from my previous facts which I have given. And the electric vehicle is the only future of the public transportation. So the battery has to play immense role. Thank you all for this listening. I will welcome if you have any question I will like to answer. please feel free to ask any question related to the battery energy storage or things.
So thank you so much, sir, for such a wonderful lecture on the batteries. You have covered almost everything related to batteries, since right from the history of the battery, to the renewable energy generation and distribution, need for energy storage, competing technology for energy storage, selection criteria, working of batteries, failure of batteries, role of carbon materials in battery technology, green future of energy storage, and the most importantly the work which India is doing. You are sitting all the way long in Norway,
Yeah.
but you have told us many things about the Indian scenario and initiatives by government, which has been really wonderful and useful for all the participants, I guess. So we have so many questions, sir.
Yeah, yeah, sure.
Let's start with the question. Mr. Sandeep Tandon has two questions. One,
Yeah.
he's asking which material is suitable to prevent the battery deep discharge, and in the same line, he's asking how the charging time is reduced if the battery undergoes deep charge.
Yeah, actually, the thing when we are going to the deep charging and discharging, generally I told in system level is different thing and material research which we are doing is the different thing. So we can manipulate in both way. First thing, if you are talking about the system level, we are doing the battery management, we can do the cutoff over there. But if you're talking about the material level, so present time, the limitation is coming not from the material, like cathode or anode material, it's coming from the electrolyte side. So basically the electrolyte which we are using is the organic electrolyte, and it's work from 1 volt to 3.5 volt around. So what is happening, this electrolyte starts decomposing. So sometimes it's good because it's forming the interface. But the problem is coming, it's removed some gases. So the first part, if I explain you about the material, so you can select some cathode, like lithium iron phosphate is there. And another side, you have the graphite present time people are using. And then you can use the battery management system to cut off the potential. Then this material is perfect. So most of the common battery use the lithium iron phosphate as a cathode and the graphite as an anode for this purpose. Because the problem is coming with the graphite, when you are going too deep in the discharge, it makes the lithium dendrites over there. And these dendrites are like a spike and it short circuit the cathode and anode because it pierces the separator. But in present time, people are looking to add the silicon into that one, which react little bit upper potential and it can give you more energy on the anode side. And we have some interesting result into this one also. I have not explained here. So by adding the silicon, you can improve the, you can minimize this dendrite problem and then you can enhance the things. So the material wise, these two things are very good nowadays.
Okay, thank you, sir. Another question is from Mr. V. Raghav Reddy.
Yeah.
Battery are always in rectangular shape.
Ah. As I showed you one slide, it's not always rectangular actually. So it's a button cell is also available, circular. And then we have a cylindrical cell and then we have a rectangular also. So it depends on application, means which application you are going to do. And mostly it's depend on the device where you are going to use the battery. So like in battery packs, we are using the cylindrical cell also and prismatic, the rectangular as he's claiming. Both cell has some plus and minus. If I explain those things, these are the engineering part of the batteries, means how you assemble. Because if you have a rectangular, you see this is a device where we are using two plates, basically cathode and anodes. These are two plates and they are coming in front of each other. So if you have a corners, so definitely the corners will have more pressure. If you do just ANSYS simulation, you will find this thing, how the electrolyte is getting distributed on the corners. So basically your efficiency of that area will be less. In cylindrical cell, you don't have this problem because it's a circular. So the force, the stress implemented on the all parts are equal, while in prismatic it is not. So it depends on the application. We are using all kind of geometry in assembling the battery packs.
Okay, thank you, sir. More question from Dr. Suresh Kumar Bhaskari. Charging the life of batteries going on to reduce. Can you explain something regarding this?
Sir, can you repeat the question? Charging a battery?
If it goes on charging, the life of battery is going to reduce. Can you explain this?
Yeah, actually, I told you about the failure mechanism of battery. So, and I told you the battery which you are getting into your market, this is already pre-activated. So whatever the initial losses we are managing at the industry level. What is the reason for this thing is two things. First thing, what kind of battery management system was used in your device where you're using the battery? First thing, like I explained you about the health of the battery, your question on the health of the battery. So it matters what kind of depth of discharge and what are the materials were used and how you are using the battery. Like I told you in my talks, always this nowadays is coming fast charging. Charge your battery in 30 minutes or 1 hour and then use it for the 12 hours. So fast charging is not good, first thing. Because what is happening when you are going for the fast charging, basically what you are doing, you are giving the current very fast to the system. Then system has some kind of kinetic limitation and thermodynamic limitations. So the ion has to come out of the crystals and it has to go another side. And in between you have the electrolyte, means you have a interface between the solid and liquid. So it has to cross that barrier also. So this is the thermodynamic limitations. Then we have a diffusion limitations. So diffusion limitations like diffusion into the solid state and diffusion into the liquid state. These matters a lot. So when you are going to charge very fast, these limits these things, and there are some new secondary reactions come into the cell, which is not in normal charging. So this gives you some irreversible product. So irreversible product means like you stored the energy 3000 milliamps into the cell. Once you do the fast charging, maybe 1% or 2% of that material is converted into the irreversible thing. So your battery life will go down. So there are lots of things, means on the management system, how much you are charging, how much you are discharging, then what rate you are charging, what rate you are discharging, and then you have material property like how much robust your material is. Like if you have a very high potential nickel and manganese based system, there the metal itself come out. So if you go with very fast rate, the collapse of the crystal is very common thing. Like your losses will be more than the 2% or 3% in per cycle. So you will lose battery very fast. So these are the things which causes the loss in the capacity with the cycle life.
Okay.
And,
Thank you. Yes. There is another question from Ms. He wants to ask, how can we increase the life of battery?
yeah, as I suggested in the previous question, is the same question. So if you want to increase with the life cycle, so I suggest two major things. First thing, don't use the fast charging until you are in very urgent mode. So fast charging may cause several things, even it cause the explosion also. And you can check when you are doing the fast charging, your heating is too much. In the back of the battery or your mobile phone, you can check. So first thing, you always prefer to do the normal charging. Battery electronics is not under your control. So it's from the device side, like the company which make the device, they use the battery management system into that one. In your hand, you have the second thing about how you use the battery. So first thing, like if you are using battery in any device, you try to charge, extract all the energy. When it gets fully discharged, then you charge it. Because what is happening with the battery has a fixed life, like 2000 cycle or 3000 cycle. So like your battery is just 50% charge and you start charging again. So what is happening, there are some chemical reactions also there at 50% charging, because sometimes we have a phase based material. So it causes some irreversible phases inside that one. But practical way, as a layman, if you think, if you charge the battery after the 50% of the discharge and charge to 100% without extracting all the energy out of that battery, you are just losing one cycle. So I will recommend this thing to do slow charging and use 100% of your battery and then next you charge.
Okay. Thank you so much, sir. This is very useful for us because we keep on charging our laptops and mobile phones before it get completely discharged. So we'll keep that in mind next time onward. Next question is from Mr. Sivakumar Nayak. He's asking, how can we estimate the efficiency of battery?
Yeah, if you are a scientist or engineer, then you have a potentiostat, basically a machine which measures the potential drop with the time and the current. So that's one way. If you are a layman, so I can tell you another method for energy efficiency. So you just charge it, your battery, when you first start using, and try to see how much time it takes to discharge, because you can't monitor the potential of the cell. You can only measure the time, and because the battery management system is not declared by the companies to you, so you just measure the time, how much time it took to get full discharge when you first use. Then after 1 month or second operations, you charge again discharge. So by this way, just comparing first cycle with the second cycle, you can find the efficiency. This is a rough way of estimation of your battery. So just time monitoring between the two discharge or two charge you can find, because what is happening, your charging rate is always faster in devices in compared to the discharge. That's why you can use your battery for longer time. So in a theoretical way, we are comparing this with the first charge with the first discharge for Coulombic efficiency. But in practical way, in a layman way, if you don't have anything, you just count the hours your mobile is running in standby mode or by using some particular apps, 2-3 apps, and then you can see how much time it took the discharge and divide the time and you can get the efficiency. That's a rough way.
Okay,
Yeah,
thank you, sir. Sir, one more. Thanks, sir. He's from our department only. He's asking lithium metal and iron, like any other battery material, lead, nickel, cadmium are not environment friendly when you dispose to open land or water.
Yeah.
What is your view on this?
Yeah, actually, if you see, the initial battery development starts with the copper, zinc, and the cadmium, because these are the common metals available at that time and easy to industrialize, because whatever we are doing research in the lab, it's not compulsory that it's going into the industry, because lots of feasibility issues, safety issues are there. So present time, like lead acid battery is still extensively used in India, but not in the world, because of the recycling of the lead. It's very harmful. Handling itself is very harmful, and I know lots of batteries people, they are changing the plate with bare hands, touching the lead plates, and they are using the sulfuric acid, which is again harmful to the body. So the thing comes with the economics. So if you need the cheaper options, people are using this lead acid battery. For solid state, they are using the lead cadmium battery. So the thing is that if you are doing proper handling of the recycling process, it is not harmful, because once battery is packed, it is packed. It is not going to harm, especially in this nickel cadmium or in the lead acid. So as I showed you, the pollution control board, they are only controlling about the lead acid battery. They don't have any procedure for the nickel cadmium. So India has to make some rules into those direction, how to control these things. But yes, with the lithium, it's lots of research is going on the recycling part, and it's very beneficial with the environment. The only problem with the lithium is very moisture sensitive and air sensitive. It catches fire, so storing lithium is an issue. But once it is packed, it's very safe. So it's always preferred. That's why most all the world is looking for the lithium-ion battery, especially lithium, and now the sodium is also coming into the picture because of the distribution of the sodium all over the world, while the lithium is very limited to some countries only. So the lithium is very good. Like I told you about the grid applications, your flow batteries are used, where the vanadium is the major salt. So it's very safe in those applications. So the world is looking now toward the more safer things, and the prices are also going down. So soon, I hope the India will also scrap is nickel cadmium things and lead acid things. It will be very soon, because new startups are coming. Yeah.
Thank you, sir. The next question is from the same person, Kaushal Nayak, sir. He's asking, could you tell some research updates on aluminum metal-based batteries, which is going to replace lithium?
Yeah, yeah. Actually, luckily you asked this question to a very good person. I worked in the lab where the aluminum battery was discovered. So I worked with that professor. So actually, his previous question is linked with the aluminum only. So in the present time where people are thinking to replace the lead acid battery, it's only possible with the lithium ion battery, aluminum ion battery, because both batteries has the potential same around 2 volt, and the capacity is huge because it's a 3 ion based things. Another options, people are looking for the aluminum air battery. Like I told you, the lithium air battery, same way they have the lithium aluminum air batteries. So the benefit of the lithium air battery is first thing, aluminum is very cheap in compared to the lithium, sodium, or your other technologies like lead also. This aluminum is very cheap, and we have one startup in India called Log9. They are using aluminum based car, and you can find the YouTube video, and some of my colleagues are working there. So they are using aluminum plate into that one, although it's a irreversible cell, not the reversible one, but the aluminum air will be a reversible cell, and it will have a very good energy density because aluminum has the +3 charge. So it really has very good things, but the issue lies in that technology is with the reversibility of the reaction. Because once aluminum oxide is formed, it's very, very tough to get it back in the form of aluminum. So people are looking for that, and we have a hope aluminum air will be the future.
Okay, sir. The next question is is there any alternative supercapacitor in battery because it is taking large?
Actually, technically, if I see about the supercapacitors, so it's like a brothers basically. Both battery and the capacitors are brother. So if you use in together, it could be a very good options. So if you think of using individually, because one is very high in energy density and other is in high in power density. So mixing up both can solve our problem. Individually, we don't think to use, because in some applications, like if you want to accelerate your bike, so you can't do it with the batteries only. You need to have some supercapacitor into the battery management system. So I don't think is there any alternate to this these things. These are complementary to each other.
One more question is there, sir. Questions are not ending because we have taken
Sure.
such an interesting topic. Mahadevi Antin is asking how to design less charging time and longer discharging time batteries.
You can charge the battery by putting the current inside the system. Okay, so like you just check your chargers. So it's coming with different specification, how many milliamps it delivers. So the first in the laboratory scale we are doing by different ways, but in practical way we are just tuning the current with the charger. The kind of charger which we are using, we are changing the current, and then we are changing the charging time. So basically, you are giving the current means you are giving or taking the electrons with the time. So if the number of electrons going per unit time is high, then your charging is high. If it is less, it's less. So that's the
Sir, two questions. The last two questions. I have we have taken
I
much
don't
of.
have any problem.
Dhananjay Chahal is asking, I heard lithium iron battery have bad environmental effects. Is it true? How much harmful it is? I think you have given answer up to some extent, but if you want to add.
Yeah, I will explain specifically for the lithium. Basically, the lithium's problem is a geopolitical problem, because as I told you, the lithium reserves are limited to some countries like Chile, and then it is exported to some countries like present time China, Japan, and US. These three major countries who contain all lithium. So if India need lithium, they have to buy. So this geopolitical problem is there. The second problem with the lithium is the safety, because I told you it's a moisture sensitive. So if you want to store lithium for manufacturing your battery, it's very tough. and it's a fire sensitive, it can easily catch the fire. But what is lucky part, like we are using lithium iron phosphate. So lithium is inside the crystal. So it is not that much sensitive. So it's very safe. The second component is coming is the electrolyte. Electrolyte also has some lithium based salt. So the electrolyte is moisture sensitive and it's flammable also. But the amount of electrolyte is very, very less. So basically, if I see environmental perspective, it is not going to contaminate, first thing. And up to now, the very less impact is known if you are going in direct contact with the lithium. So the fire hazard is only hazard which is with the lithium if it got exposed. Or like some, you have a used cell, I will tell you one thing which you don't do. If you have any used cell, don't hammer it. Because generally what is happening, when cell got used, your lithium from the metal crystal come out and it deposited on the anode part. So once you hammer it, come in contact with the oxygen, it will catch fire. So never try to hammer your cell or your mobile device once it is used, because then whole component will come in contact with the air and catch fire. So this is the only drawback I can see for the lithium metal applications.
Okay, sir, thank you. And one question is there from Paveen Kumar. Nowadays, mobile companies are claiming to develop fast chargers. Is it really possible to charge at such a fast rate without compromising the battery performance as claimed? I think you have partially answered this too.
Yeah, actually, I have shown you one of my result in the thin film batteries where you can charge the battery within 10 minutes. So it is possible. But what you compromise, if you just see that result, I showed you when you charge the battery in 1 hour, you get the capacity around 300 milliamps. When you discharge at 10 C means 10 minutes just, and you get the capacity around not 10 minutes, it's just 6 minutes. So you get capacity 100. So you just lost your capacity. So compromising, if you think, means your battery is under stress. When, like I told you, once you want to charge very fast, so it's good for emergency condition, but not for always. It compromises with the life cycle, not with the capacity. Capacity slowly it will lose. Because if you charge with the fast charging in 1 day, and then after 2 days, 3 days, you do the charging with the slow rate, it will gain almost the same. Very less loss is there. But always if you are charging with the fast rate, definitely the life will go down, because of the irreversible reactions which is coming because of the electrochemical stress on the material. So their claim is that sometimes they are using very fancy word. Companies are using very fancy word to sell their products. So it's up to them only. But technically, it's not the fact.
Sir, one last question. This is not the technical one. I have heard that while using your laptop, I mean, just as you say, when you have just drained all your batteries, then charge again to full and use it completely. But in the case of laptop, it doesn't use actually that. And I have heard somewhere that while using the laptop, you need to connect it to the port, and as longer as you are using, you get it connected to the charger. So does it? I mean, what are the suggestions from your side?
No, actually, see, it's this devices where we are using high potential things. So we have a battery management system, very good electronic system. It's not internally controlled, but it's externally, because I told you we can use some chemical inside the battery to control the potential. And we have another electronic board which bypass the current. Means once it's a very definite kind of leveling of the potential based things. So once your battery is reaching to the 4 volt, it bypass the current to the system. So the system will not drain any current from the batteries. So if you are using in batteries in fully charged condition, means your laptop is plugged in, so that time the battery charging is bypassed and the current directly going to your system. So it's not harming to the battery. But yes, I will suggest you one thing. If you do this kind of thing all of the year without discharging the battery, so the battery has the something called the self-discharge property, or the corrosion, electrochemical corrosion. So if you keep your battery always at the 4 volt, it will corrode the electrode. So the cycle will lose. So what you have to do, like in some 1 month, 30 days, 20 days, once you have to drain full energy of the battery without plugging. So that could be a smart way to use your laptop for longer battery life in the laptops.
Thank you so much, sir. This is really need of the hour because whole the day long we are taking online classes and these kind of questions. So this is the very wonderful tip you have shared with us. And thank you for the whole lecture, sir. We are getting all the comments from the participant in our chat box that they really like the session. And we all, the faculty members who are connected, really because the session has been stretched to 1 hour to 2 hour almost. So thank
Yeah.
you so much, sir, for such a wonderful lecture, and we'll be in touch with you for
Yes, sir.
seeking the guidance related to your research area related to this. And you are so humble, so approachable. Thank you so much for being here with us. And one more thing, I just wanted to show you the certificate, which is the gratitude which we can share with you right now. I'll later on the certificate to you. So can you see the certificate, sir?
Not yet. Yes, yeah, now I can see. Yeah, thanks very much to the all Sagar institution team, and I'm very thankful for giving this platform and just to share this knowledge, and very thankful to you also for communicating all the way so many things in the meantime. I'm very thankful to you all guys.
Thank you so much, sir, and all the participants. This session was gone really very well, and I think there are many takeaways from all the participants. As I have many takeaways, and lastly, the important tip related to laptop charging. Thank you so much,
Yes.
everyone. We'll see the participant. We'll be connecting for our next session tomorrow morning, 11 a.m. And thank you, everyone. Thank you, sir, again and again.
Thanks. Bye bye.
Okay, good day.